Good morning, respected teachers and my dear friends. My name is Muhammad Salman. I am from Mechanical Engineering second year, first semester. Today I would like to explain about my topic, the process of hardenability and surface hardening in the heat treatment. My subject name, the material science and metallurgy. My subject code 23MEC303. My topic name, the process of hardenability and surface hardening in heat treatment. Hardening heat treatment process. Contents: the introduction to hardenability, surface hardening, importance of hardenability, factors influencing the hardenability, measuring hardenability, overview of the surface hardenability techniques, case hardening process, introduction hardening method, nitriding process, application of hardenability and surface hardening. My first topic, introduction to hardenability and surface hardening process. The hardenability refers to materials' ability to harden in depth when subjected to heat treatment. Surface hardening enhances the wear resistance of the metal's surface while maintaining a rough core. Right side image, the hardenability of the steel, the mountain finishing and the Jominy specimen is explains about the hardenability and the surface hardening. Understanding this process is crucial in various applications, particularly in steel manufacturing. Importance of hardenability. Hardenability affects the mechanical properties of the steel and it performs in various applications. Material with high hardenability can achieve uniform hardness throughout their cross section. It plays a critical role in the design of components that require strength and roughness. The surface hardening and the case hardening are heat treatment processes that involve heating and the cooling metals to change their properties. Surface hardening, a cost of effective way to make the specific area of the casting the more resisting wear. Common method include the flame and induction hardening. Case hardening, a process that makes the surface of a metal harder while the deeper part soft. This creates a layer of harder metal on the surface which increase the metal's wear resistance and toughness. The case hardening is often used for the low carbon steel or iron and for metals that need hard surface and critical core like gears, bearings and shafts. Here are some details about the processes. Flame hardening. The surface layer is heated above the critical temperature to from essence and their quenched to form hard martensile. The core of the metal remains unhardened and the case hardening. The metal is heated until it's the red hot. When quenched in the cool liquid, this process is repeated to create the hardened surface around the unchanged core. Cooling rate. The cooling rate during the quenching the critical to the process of the steel in the held at the high temperature and the cool too slowly it would not transfer from essence to martensite. Instead it will revert back to the softened mix. Factors influencing hardenability. The allowing elements represent in the steel significantly the impacts of hardenability. Cooling rates during the quenching process also determine the degree of hardening achievement. The initial microstructure of the steel prior to steel heat treatment is the another critical influencing the factor. The factors that affecting the hardening process. The properties of the hardened steel depends upon the following factors. chemical composition, size and the shape of the steel part, hardening cycle, homogeneity and the grain size of austenite, quenching media, surface conditioning of the steel apart. Measuring hardenability. Hardenability is often measured using the Jominy test, which provides a standard method for evaluation. The, stat- the test involves heating a steel, allowing a hardness to be measured at various distances. The results helps in the understanding how the different alloys respond to the heat treatment. Overview the surface hardening techniques. Surface hardening techniques include the methods like case hardening, introduction hardening, and trading. These processes can improve the wear resistance without compromising the core's ductility and toughness. Each method has its own advantages and is chosen based upon the application requirements. The right side image that explains about the intergraduation capacity, the time of evaluation, the development of the surface hardening techniques, the case hardening and the flame hardening, induction hardening, laser hardening, and grain handling. Case hardening process. The case hardening involves in the creating a hard outer layer while keeping the internal structure softer. The techniques such as the carbozing or carbonite, carbonating used to introduce the carbon into the surface layer. The right side image the case hardening the heat treatment process. Using the gas or air control, the steel rod is heated. The results enhance the wear resistance, the fatigue strength, and for components like gears and shafts. Introduction to hardening method. Introduction to hardening uses to electromagnetic induction to heat the surface of the metal rapidly. The following heating the part quenched to achieve the hard surface layer. This method is effective for the high volume introduction can be previously controlled. The right side image explains how the hardening method is done by the electromagnetic induction, the heat process. Next process, nidring process. Nidring process is a diffusion process that introduces nitrogen into the surface of the steel. The right side image explains the oxide layers, white layers, diffusion zone. The oxide layers running in the layer, friction decreasing, corrosion resistant. White layer, protection against the abrasive and the adhesive wear. Low friction coefficients, high hardness. Diffusion layer, high compressive stress, high fatigue strength, hardness higher than the substance. Nitriding is the diffusion process that introduces nitrogen into the surface of the steel. It produces a hard wear resistance layer without the need for the quenching. This method is particularly advanced for the components requiring the high fatigue strength and the corrosion resistance. Application of hardenability and the surface hardening. High hardness steels are widely used in automotive and aerospace industries. For the critical components, the tools and the dies often utilize the hardening techniques to extend their service life. Understanding these processes allows engineers to design more durable and efficient products. The right side image explains the hardened layer of the surface layer and austenize the surface layer. The flames are used to the hardening the surface. Conclusion. The process of hardenability and the surface hardening are the essential optimizing the material. The right side image explains the The hardening process. In the use of introduction, the heat the metal parts heated by the austenite phase. The fast quenching process transform to austenite to materials in the phase. The process totally using the hardenability surface for the essential optimizing the material performance. The advances in these techniques continue to enhance the capabilities of modern engineering materials. Ongoing this research and developments will ensure that this process remains relevant in the future applications. The heating process, the Joule heat by the Ide current and electromagnetic field induction, and the next to high frequency the process used in the workpiece and inductor coil. This is called the induction of hardening process. Here are some advantages of surface hardening and heat treatment process. The case hardening. This process creates the hardware resistant surface layer while keeping the core ductile. It often used on mechanical parts like bearings and gears. Induction hardening. This process can improve the good dimensional stability and stress less distortion and the other surface hardening method. It can also improve the parts strength and toughness life. Synchronous treatment. This process can improve the wear properties, reduce the friction and increase the dimensional stability. It can also make the machining easier and reduce the stress friction. The other advantages. Tempering. These methods slowly lower the hardness but significantly increase the strength. The commonly method of the hardening the part in both conventional and PM manufacturing. Laser hardening. This process can result in negligible distortion and precise case depths. It's faster than the other processes like furnace, carbonizing and nitrating, ion nitrating. This process can be used to case hardening titanium alloy, stainless steels, and alloy plates. It can also reduce the energy, the consumption, the gas consumption, and the environment pollution. It helps in the environmental to less pollution. It is about the advantages of surface hardening and the heat treatment process. Disadvantages. Surface hardening and heat treatment process have several disadvantages. Distortion. The rapid heating and the heat cooling process can cause distortion which can problem if component needs to be precise size or prone in warping. Creasing. The process can lead interangular cracking due to thermal expansion and the constriction of impurities like grain boundaries. Material limitation. Not all, not all materials can be used in the process. For example, induction hardening is limited to specific grades of level steels alloy and the low carbon alloys don't perform the well. References. The heat treatment selection by the application of the tools, the steels by William E. Borsan. The material science and engineering, an introduction by William D. Salstel Jr. ASM Handbook the volume for heat treating by ASM International. Thank you.